All right. So this is the last video uh, for the discussion of the library functions of the string class. Now let's begin with a compareTo. Now this is quite an important function for our prediction questions, so please listen carefully. All right. Now what is the use of compareTo? You see, we have already discussed about equals and equals ignore case in the previous video. And that function was used to compare for equality between two strings. But there might be cases where you would be asked to sort the strings in a particular order, either in ascending order or descending order. So then you would need a way to compare two strings, which one's greater, which one's smaller, right? Now, as strings are implemented in Java, we cannot use relational operators to compare the content of two strings. We need to make use of functions, right? So therefore, compareTo function comes into play. Now, this function lets us perform lexicographical comparisons. Now, what does this mean, lexicographical comparison? Now, lexicographical comparison means, or lexicographical order means the order in which the words are arranged in a dictionary. Now, in a dictionary, the words are arranged from starting from A to words that start with Z, right? And then they're arranged in a particular order, and this order is referred to as the lexicographical order. Now, this compareTo function would compare the strings x and y, as is evident from here, x and y, and it would give you a number, an integer, right? Now, the integer can be of three kinds. Let's say I store the integer in a variable called n. Now, the value of n can be classified into three groups. Now, n can either be greater than 0, or the value of n can be equal to 0, or the value of n can be less than 0. Now, for each of these three categories of values, we have a different interpretation. If n is greater than 0, that would mean that x is greater than y. Or in other words, x comes after y in lexicographical order, when sorted in lexicographical order or ascending order. That is. Now, if n is equal to 0, that would mean that the content of x and y are the same. All right. And if the value of n is less than 0, that would mean that x is less than y, or in other words, x comes before y when sorted in an ascending order. All right. Now, now that how the value of n is clear, the return value of compareTo function is clear, we must also understand how the value is generated, how the value of n is generated. That's our next topic of discussion. Now, this is pretty important for output prediction. All right. Now, there can be two cases in which compareTo can work, right? compareTo could work. Well, let's discuss the first case. The first case is when at least one character is different between the two strings. So here, for example, I have two strings, str1 and str2. Now, these two strings are different in many places, right? But the first place in which they are different is this. BAT are same in two strings, but they are different at this two characters first. All right. Now, what compareTo would do in this case? compareTo would subtract the ASCII of these two characters. So, ASCII of M would be subtracted from the ASCII of W. Now, you might ask, why not the other way around? Well, the function call was as follows. In n equals str1.compareTo str2, meaning the characters of str1 would, or I'm really sorry, the characters of str2 would be subtracted from str1. All right. So the ASCII of M, ASCII of W will be subtracted from the ASCII of M. Now, what would we get in this case? Well, we already know that the ASCII of capital A is 65, right? We already know this. I don't have any space to write that. Let's write it here. The ASCII of capital A is 65. Now here I have made a small table that contains letters from A to Z with having numbers from 0 to 25. Now, let's say I want to find out the ASCII of A. What I would do is I would add this number with 65 to get back the ASCII of A or any character. For example, let's say I want to get back the ASCII of D. How would I do that? I would add 65 to 3 and I would get back 68, which is the ASCII of D. So following this, I can get the ASCII of M as well. You see M is at position 12, so the ASCII of M would be 65 plus 12, right? Minus ASCII of W, well, W is at position 22, therefore the ASCII of it is 25 plus 22. But if you see, in effect, we are only subtracting the position of these two characters, right? You see, 65 and 65 would eventually get cancelled, right? And the only thing that will be left is 12. And therefore, we are subtracting 22 from 12, which gives us minus 10. And this means that str1 comes before str2 when sorted in a lexicographical order, right? Let's see the second case. Okay. Now, in the second case, the characters, there are no characters where the strings differ. For example, let's say this could happen if the strings are equal, right? So here str1 and str2 contain the same thing. So B and B are equal, A and A are equal, T and T are equal. Therefore, there are no characters which are different in these two strings. So what happens in these cases is that the length of these two strings are subtracted. So for example, the length of str1 is 3. So is the length of str2. So if you subtract their two lengths, then we would get back 0, right? str2 dot length would get back 0. This would be str1. And this would indicate that two strings are equal, and they are equal in fact, right? Now, there can be another case, or not another case, there can be another point where no character is different in the two strings. So let's say, for example, we have two strings where the first string is card and the second string is cart, right? So you see, both the strings have the same characters, but differing in just T. But there isn't any fourth character on str1, so we cannot really say that the characters between these two strings are different, right? At least some of it matches. A complete string matches with another string, right? So in this case too, what we're going to do is we're going to subtract their lengths. And if we subtract their lengths, then we would be left with -1, and the value of n is -1, which means that car comes before cart, and that is true. If we check the dictionary, you will see that car will come before cart. All right. So this is how compareTo works. But there's another thing that you must remember about compareTo. Well, compareTo does case-sensitive comparisons. All right. Now, before I move on to that or jump on to that, let's recap how compareTo works once again. So in case 1, where at least one character is different, you would stop at a character where there is a difference, the first character where there lies a difference, and you would subtract the ASCIIs of these two characters. And whatever you are left with will be the value of n, and the sign of this value would determine your interpretation, right? And there's case 2, and in case 2, there could be two sub-cases. Firstly, where the strings are equal, and if the strings are equal, in case 2, in general, you subtract their lengths. Now, if you subtract the length where these two strings are equal, you would get back 0, and that would mean that your strings are equal. Now, in the second sub-case, if where the strings are different but no character is different, you would get back -1, as in for this example. You would subtract their lengths. That's what I'm trying to highlight here. In case 2, you are going to subtract their lengths and not the characters, because there are no position of difference. All right. Now, compareTo does case-sensitive comparisons. What does that mean? It means that it does not consider characters from different cases equal. They are different. So here, the point of difference would exist in the first character, B and small b. Though they are same to us, they are not same to compare to. And now, if we were to subtract the ASCII of B from the ASCII of A, this is what we are going to get. Now, we know that the ASCII of B would be 66. 65 plus 1 gives you 66. 65 plus 1 minus B, well, the ASCII of B is 97 plus 1, right? Now, if you subtract this two, you get 66 minus 98, and that is, I hope, minus 32. So therefore, capital BAT would come before small BAT if you compare them with compareTo function, because it does case-sensitive comparisons. All right. Now, I hope it's clear. I'm really sorry about this. Now, I hope it's clear how compareTo works. Let's move on to the next form of compareTo, which does case-insensitive comparisons. Now, this function is named compareToIgnoreCase, like you had equals ignoreCase. Now, this works in a similar fashion to compareTo. The only point of difference is that it does not take the case into consideration. So if you compare capital BAT with lowercase BAT, you will get back 0, because it compareToIgnoreCase takes these two strings to be equal. All right. Let's see that example. So here, this value would be 0, because these two strings have the same content, leaving the case. Okay. Now, let's understand about the trim function. Now, this function is also important for word extraction problems. Now, what this function does is it trims or cuts away or chops away chops off the leading and the trailing spaces that are present in the string. So, what do I mean by leading and trailing spaces? Consider this string, for example. So this string has a few spaces in front, followed by cat, and followed by some spaces at rear, right? So the spaces that are in front of cat are known as leading spaces. And the spaces that are after the letters are known as trailing spaces. Now, if you want to remove these unwanted spaces from your string, you would in fact call the trim function. Now, as all functions in string class is written, it does not change the content of the string, but what it does is it returns a new string that consists of the string without the leading and the trailing spaces. So therefore, you get cat. But the original string has not been modified. The original string is still this mess of spaces, right? So if you want to store the trimmed string as your str, then what you need to do is you need to perform reassignment. So okay, before let's jump onto that, jump onto reassignment part. So here you would write str equals str dot trim, and then your original string would contain the part without the leading and the trailing spaces. Now there's one more fact that I want to highlight about the trim function. The trim function only deals with the leading and the trailing spaces. It cannot delete the spaces that remains in between words. So for example, here, the spaces that are in between words are these, and trim cannot delete these spaces from the string. All right. So it can only delete the leading and the trailing spaces, but it cannot delete the spaces that are inside of or enclosed between two words. All right. So the output of this function called str.trim would be spider, and it would contain the three spaces followed by man. All right. And as I've already said, it does not change the content of the original string. It only computes a new string and it returns that. Hence, the original string, if printed, would contain the same old output. Spider, many spaces, followed by man. All right. Let's move on to the next function. Now, this function is used to check whether x starts with a prefix y. All right. So this is how it's called. X dot starts with y, two strings, and it returns a Boolean type. So here I have two examples. It is best explained with the help of an example. The first string is bat, and the second string is Batman, and the second string is bat. Right. Now, Batman has a prefix bat. Therefore, str1 dot starts with str2 would give you true. But this will not work the other way around. If you call str2 dot starts with str1, this would give you false because bat does not start with Batman, right? So the ordering does matter. Moreover, it's case sensitive, meaning if you passed bat in lowercase letters to this function and you expected it would return true, that's not the case. It would return false because this string does not begin with lowercase letters BAT, right? Let's move on to the next function. Now, this next function is the exact opposite. It checks for if a string has a suffix y, if x has a suffix y or not, right? So Batman ends with man, therefore this function would return true in this case, right? And this is also case sensitive, meaning if you passed lowercase letter man, it would return false. Now, this doesn't work the other way around. If you have written str2 dot ends with str1, this would have not worked for obvious reasons, right? Let's move on to our last function of the library class. Now, our last function is named contains, and this is used to check if x contains any sequence of y characters. You see, it's best explained through an example, so let's see that. So here I have a string called Corsair, and here another string called RSA. And we need to check if str1 contains any sequence of characters that's R, S, and A. Well, it does, right? So we have R, S, and A as a part of Corsair, right? Therefore, str1 dot contains str2 would return true. But this is not true the other way around. Moreover, this is case sensitive, which is why if you had written RSA in lowercase, or let's say hair in lowercase, this would have not worked. But still, let's use hair, right? You see, only AIR matches, but there's no H, right? Therefore, this function call would return you false. Now, if there's any doubt regarding any of these functions, you may go over these examples once again, and I hope you would get this because it's quite easy to understand through examples, and I've given you plenty of examples to begin with, right? And if you have any trouble, watch this video a couple of times, it will be clearer to you, all right? So that's it for the library functions of the string class. I'll see you in another video. Bye for now.